Hi, welcome to Chapter 7. Okay, so we're going to start a new chapter here. Chapter 7, Section 1, we're going to be talking all about angles for this first section. The objective of our section is to find the measure of an angle in either degrees or radians. So this should look familiar from Algebra 2B. And we're going to define this word, coterminal angles. So these are basically our three vocabulary terms for this section. We're going to talk about degrees, we're going to talk about radians, we're going to talk about coterminal angles. Okay, so let's get right into this. So first thing we need to talk about, trigonometry. Trigonometry, all it means is triangle measurement. Okay, it deals a lot with triangles and it deals a lot with angles. Okay, angles and triangles are what trigonometry is basically all about. Okay, so we have basically a very simple angle here. And you notice the angle is going up because of the angle head, so you always have to tell which direction your angle is going. If you don't put an arrowhead, it could go down or it could go up, so it could either be a negative angle or a positive. This one is actually going up, so it is a positive angle, but we'll talk more about that a little bit later. Okay, so the blue line here is where the angle starts, so it's called the initial side. Okay, where an angle starts is called the initial side. Where the angle ends up at the top here is called the terminal side. And we can remember terminal, that is because that is where airplanes land. They land at an airplane terminal. Angles finish at the terminal side. Okay. Now, angles also have two different types of measures. One measure is degrees. Okay, one is degrees and the other one is radians. So this is just like degrees Celsius and degrees Fahrenheit. There are two different measures for temperature. Actually, there's three. We can also talk about Kelvin, but the two main ones are Celsius and Fahrenheit. Angles are measured in two different ways. We have degrees and we have radians. Okay? We always know something is in degrees if there is a degree symbol. If it does not have a degree symbol, it is not a degree measurement. Okay? If it doesn't have a degree symbol, then we know it is a radian. So for instance, if all you see is 6, and we know we're talking about an angle, this is 6 radians. So we usually abbreviate radian with rads, so 6 radians. Or a lot of times radians will have a form of pi in it. So for instance, 3 pi over 5 radians. Okay, so the easiest way to tell if it is a degrees or radians is this degree symbol. If you do not see a degree symbol, it is not in degrees, and you have to assume that it's in radians. All right, so we need to be able to convert back and forth from degrees to radians and radians to degrees. So our two methods that we use, we have two conversion factors. We have pi over 180 and 180 over pi. Okay, and there is a very simple way to tell which one is which. So let's do two examples, one of each. Okay, the first one, we're going to convert from degrees to radians. So let's say we have 30 degrees and we want to convert that to radians. We're going to multiply by whatever one we're starting with. If we're starting with degrees, we have to use the one that has degrees on the bottom. So we're going to do pi over 180 degrees. Okay, so if we're starting with degrees, we're going to multiply by the one with degrees on the bottom. Okay, so what I like to do is I like to simplify first. Degrees over degrees cancel. If I divide 30 by 10 and 180 by 10, the zeros cancel. If I take 3 goes into 3 once, 3 goes into 18 6 times. And then everything else has been simplified now. So on top, I multiply straight across. 1 times pi is pi, and 1 times 6 is 6. So it's pi over 6 radians. That's my first one. So that's going from degrees to radians. Now let's go from radians to degrees. So let's just do pi over 6. So we can see that it should equal 30 degrees. Okay, so now we're starting with radians, so pi needs to go on the bottom. So if you're starting with radians, we need to have pi on the bottom when we multiply. So I'm going to put pi on the bottom, and I'm going to put 180 on top. So pi over pi cancel. 6 goes into 6 once, 6 goes into 180 30 times. So I have pi times 30 is 30, 1 times 1 is 1, I don't need to put over 1, so there it is, 30 degrees. Okay, so you multiply by pi over 180 or 180 over pi, depending on what you start with. Okay, So if you're starting with degrees, you're going to multiply by pi over 180. If you're starting with radians, you're going to start with 180 over pi. All right, hopefully that's easy enough. All right, now let's talk a little bit about degrees and radians. Okay, and remember, this is like the unit circle which we learned about, that you should have learned about in Algebra 2. Okay, let me make this a little bit smaller here. Okay, so the main device we use for radians and degrees is called the unit circle. Okay, so it's an XY plane with a circle attached to it. All right, and we always start at 0 degrees, and then we have a 90-degree angle, so 90 degrees is up here, and then hopefully 90 plus 90 is 180, and then hopefully 90 plus 90 plus 90 plus 90 is 270. And then when we finish back up here, we have a full circle all the way around is 360 degrees. Now, each of these numbers, every degree has a number that's attached to it that is a radian measure. So if we look down here at this chart, 0 degrees, if we look at this chart here, 0 degrees is 0 radians. 45 degrees is pi over 4, 90 is pi over 2, 135 is 3 pi over 4, 180 is 1 pi, 225, and so on. So everywhere you go, and the unit circles are typically broken down into 3 important angles. They could go all by 45s, you could go by 60s, and you could go by 30 degrees. Okay, and each of those has a radian measure that's attached to it. Okay, and we'll talk much more about this in section 4. I just kind of want to give you an idea that every single degree, for instance 60 degrees, has a radian measure of pi over 3. 120 is 2 pi over 3, 180 is 1 pi, 240 is 4 pi over 3, 300 is 5 pi over 3, and 0 is 0. Same thing with 30s. 30 degrees is pi over 6, 150 is 5 pi over 6, and so on. Okay, so the unit circle, degrees and radians, they go together. They're just like Celsius and Fahrenheit in measures of temperature. Okay, so we also need to be able to draw an angle. Okay, so when we draw angles, it has to be done a certain way. Okay, so let's start off with a positive angle. Okay, let's draw an angle of, let's see, 75 degrees. Okay, so we always start on the positive x-axis. Okay, oops, that did not look good. Get rid of that. We're going to start on the positive x-axis. Okay, we're going to go up. Up is positive. And we're going to go to an angle that we feel looks like 75 degrees. Okay, it does not need to be perfect. I actually don't really like that angle. So I'm going to start again. Okay, it's more than 45, but it's less than 90. I think I like that one a little bit better. So we need 3 arrowheads. One for our initial side, one for the direction of our angle, and then one for our terminal side. And we also need to mark in there that that's 75 degrees. Now we're not using a protractor here. We're just guesstimating, and that looks pretty much like 75 degrees. Okay, so let's say I gave you negative 210 degrees, and I want you to do that one. Now, instead of going up, we're going to go down first, because up angles are positive, down angles are negative. So here would be, okay, I'm going to draw my initial side first. Don't want to forget that. Here's negative 90, negative 180, and now I need to go 30 more degrees about to get to my negative 210, and then you're going to finish it off with your arrowhead. Okay, so there's negative 210 degrees. All right, so positive angles go up, negative angles go down. All right, so I think that should be good. I think drawing angles is fairly easy for you. So positive angles go up, negative angles go down. Don't forget that. All right, so the last thing we need to talk about in section 1 is this idea of coterminal angles. And these are angles that share the same terminal side. And they can be both positive and negative. Okay, so let's do an example. Let's figure out first off what this means. All right, so let's say we have a 45 degree angle. Okay, so let's say that's 45 degrees. All right, now our terminal side, this side right here is our terminal side. So coterminal angles have to share the same terminal side. Well, how is the only way on here that I'm going to be able to get back to the same terminal side as 45 degrees unless I go all the way around again? So what have I done to 45 degrees? I've added one complete circle. One complete circle, remember, is 360 degrees. So 45 degrees plus 365 degrees is how much? I'm sorry, not 365. Sorry, let me start again. My fault. We're taking 45 degrees and we're adding 360 degrees to it. So what's 45 plus 360? Okay, for those of you who want to see this, 360 plus 45 is a pretty easy one to add in your head, 405 degrees. So we have a 405 degrees. These angles are coterminal. Okay, now what happens if I did it again? What happens if I went all the way around one whole complete circle again from where I was? Now we would have 405 degrees plus 360, and that would still be on the same side. So what is that one? So 405 plus 360 is equal to 765 degrees. So there's another coterminal angle. And you could keep doing this forever and ever and ever. You could keep getting bigger and bigger and bigger angles. Okay. Now, what happens if I want to get rid of that? And now those are positive angles. What happens if I want a negative coterminal angle? So I'm going to draw in that same 45 degree angle. 45 degrees. And what happens if I wanted a negative coterminal angle? So what happens if I went the opposite direction? I did a negative angle. So instead of adding 360, I would have to subtract 360 degrees because I went negative. So now I'd have to do 45 minus 360. Okay, so let me get my calculator. 45 minus 360 is what? Negative 315 degrees. So a negative coterminal angle would be negative, sorry, I already forgot it, negative 315. Negative 315 degrees. And you could keep doing that again and again and again and keep subtracting 360. So to get a positive coterminal angle, you would add 360 degrees. And to get a negative coterminal angle, you would subtract 360 degrees. Very simple math here. Okay, let's do two examples, one with degrees, one with radians, and then we're done. All right, so what it says is find one positive and one negative coterminal angle for 110 degrees. All right, so let's first draw 110 degrees. Okay, there's 90, so we have to go like another 20 degrees. Okay, that's about 110. Okay, so from 110, if I do a one whole complete positive circle, I get 110 plus 360 degrees is equal to 0 plus 0 is 0, 1 plus 6 is 7, 1 plus 3 is 4. So 470 degrees would be my positive coterminal angle. And to get my negative, I would just do the opposite. I would subtract 360. So what's 110 minus 360? Let's use our calculator for this one. 110 take away 360 is negative 250 degrees. Negative 250 degrees. So here is my positive coterminal, and here is my negative coterminal. All right, let's look at example 2. Now, it says find one positive, one negative coterminal angle for 5 pi over 4. Now, you could convert this into degrees first, or you could just use radians. So if we go back to our unit circle pictures, what is, I don't think it says here, I don't think it says on this picture, but let me write it down on this example. 360 degrees is equal to 2 pi radians. So instead of adding 360 or subtracting 360, we're just going to add 2 pi or subtract 2 pi. So it's pretty simple. So let's do 5 pi over 4, and we're going to add 2 pi, and we'll just put it over 1 to make it a fraction. So now we just need a common denominator. What would be the common denominator here? Hopefully you can see that it would be 4. 1 times 4 is 4. 2 pi times 4 is 8 pi. So what's 5 pi over 4 plus 8 pi over 4? That would be 13 pi over 4. So there's my positive coterminal angle. And then we do the exact same thing, but instead of adding 8 pi over 4, we're just going to subtract 8 pi over 4 to get our negative. 5 pi over 4 minus 8 pi over 4 is negative 3 pi over 4. And there is our negative. Now, you could convert 5 pi over 4 to degrees, add 360, subtract 360, but then you would have to turn them back into radians when you're done, because if it's starting with radians, you need to finish in radians. I personally would just rather you can convert using the 2 pi as a conversion factor. So you're going to add 2 pi and you're going to subtract 2 pi. Okay, so that does it. That's section 7.1. I will see you tomorrow. Have a good night.